All right, hi, my name is Major Mel Lake. I'm OC of 2-4 Field Squadron at 2CR. So I received the task for up Winisk from my CO once it came down through the chain. Nick Saunders here with me today from TCC. He actually had a much larger role at the front end of this than I did. So
thanks. Yep. You can go to the next slide, please. So my name is Nick Sanders. I work with the, it used to be called the UXO and Legacy Sites Program. It is now the UXO and Contaminated Sites Program. I work with Defense Construction Canada, and my job is to support that side of national defense. So I'm going to play that video quickly.
Oh yeah. That was a good one.
4 Alpha, all sentries, 2 booms, 10-minute soak time now, out.
So that was the problem solved right there. And now to go into the problem, go to the next slide, please. So Winisk, Mid-Canada Site 500. It's located, as you can see, up on Hudson Bay, in the middle of nowhere, basically, near a small community called Winisk, about 200 to 300 people. The site was established in 1956 as part of the Mid-Canada Line. It was a sector control site for the Mid-Canada Radar Line site. It was basically active until about 1965, and the site itself was used heavily for also the development of the DEW line, so construction of the DEW line. So it was used to ferry in supplies up north to the construction of the distant early warning line, the DEW line site. And as with many of these sites, especially the ones abandoned in the 50s and 60s, the military's footprint was visible long after site closure. The site itself, you can see on the slides on this side, was contaminated heavily with things like PCBs, hydrocarbons, and other contaminants. And for years, the locals, the Winisk First Nation, and the Ontario government lobbied the federal government to help them with the cleanup of the site. In 2009, D&D entered into a contribution agreement with the Ontario Ministry of Natural Resources to help fund part of the cleanup. And as they were doing the research on these sites, I was sent in 2010, if you go to the next slide, please. I was sent that blurry photo, what looks like pipes extruding from some sort of embankment. We did some research on this, and it turned out that these pipes were installed into this gravel pile and filled with explosives. Now, why do they need a big gravel pile? You can see the pile right here. Well, we're in the Hudson Bay lowlands, and there's no aggregate resources. And they needed these gravel to help with the maintenance of the runway. And so they, just off-site, built a huge gravel pile. It's about 30 meters high, and the front face is itself about 150 meters long. They built this pile, drove pipes into it, and filled those pipes with explosives so they could have access to the gravel in the winter months. Now, at site closure, they basically left the stuff there. And actually, in 1965, there was a local who was operating a backhoe, drove the backhoe into the side of it, and some of the explosives detonated. So there was actually a death on the site. As we found out, there were over 50 pipes in the pile, and a majority of those pipes still had explosives in them. In 2006 and 2007, the OPP actually visited the site, and actually, as Major Lake will talk about later, they actually made the situation worse because they obscured a lot of the pipes by cutting them off. Next slide, please. So, just to talk about a little bit of the community. So, community of Winisk, which is a new community. The original community of Winisk was just up across the river. It was destroyed in a flood in 1986. So they built the community of Winisk 35 kilometers upstream. It is on it's the last stop on the Air Quebec Milk Run up the Hudson Bay coast. And it's also on the border of Polar Bear Provincial Park. And you can see those polar bear footprints were on the shoreline taken in between the actual task site and where the 2CR had set up its camp. Also, it's inaccessible. As you can see that top slide there, it's muskeg all across. And you're not getting anywhere in the summer months except up and down that river. So the river itself was the main use of the site, main use of transport. In addition, they used that site as a vantage point for hunting. So because it's flat, that was the highest point. A lot of the locals would use it for hunting. And because there was explosives there, we had to get out and do something. Next slide, please. So you can see where we're talking about exactly. Next slide. And then the community, if you want it, down here, you can see the Winisk River goes up, and that's Hudson Bay right at the north of that slide. Next slide, please. Now, the usual course of action that I would use in my DCC role is I would get a statement of requirements from my D&D project director, and I would go and run, contract out a UXO contractor to fix the site. But we immediately ran into a roadblock where, from a regulatory perspective, this wasn't a UXO, and our UXO contractors were not permitted to actually go out and do this work. So my only resource was able to use the CF to get this done. And the reason why it was considered while UXO contracts are not permitted is because the Directorate of Ammunition and Explosive Regulation saw it somewhere along the spectrum of an IED and a Bangalore torpedo. So they said UXO contractors were not allowed, we had to use the CF. So now, the original plan was to use it as a training mission. This was back in 2010. That got a little bit of traction. I went up on a recce 2011 with 2CR, but because it wasn't a priority and there was no real drive from the leadership to get this done, nothing really happened. Nothing came of it, mainly because those other groups had other priorities and other exercises and other tasks they needed to deal with. So it really went nowhere until, thanks to General Whitecross, we were able to push a CDSDM directive to get this site dealt with. Basically, the directive said, get it done by September of 2013. And once that got the ball rolling, it was a snowball effect, and we had a project start getting planned. And one of the keys to the success of the project was the development of an SOR, where we said, what's the desired outcome of this project? What do we want to see on that gravel pile? What's the risk profile? How do we want to reduce it on the gravel pile? And we took that desired outcome and worked backwards. And I worked with CJOC and 2CR to develop a tight SOR that really said, okay, how can we call this operation a success, and how can we make this safe? We put those two together, and we had our outcome. Once we had that SOR developed, my role was to take a step back and basically let the Army deal with this problem. That's where this project landed on the desk of Major Lake.
Great, next slide there. I apologize, when I was doing our introductions, I neglected to introduce Warren Schrader. He's the Sergeant Major for 2-4 and has been involved in this since 2011. So next slide then, please. So where Nick ended off with that statement of requirements, that's really where we picked this up, like he said. We basically, that SOR translated into the end state for our mission. So when we wrote our concept of operations, we had a very clearly defined end state that we had to achieve. The main thing of that was that that front gravel face there had to be free from metal pipes and explosives up to either the length of the pipe or the limit of the depth of our detection devices, so 30 to 45 centimeters. So that's what we started with, including a few parameters in that we had to do this, minimizing our footprint on the ground and the environmental footprint that we left behind. Next slide. So starting this, when this landed on my desk, what we knew, we had the luxury of having Warren Schrader, who actually in 2011, when Nick went up on that second recce, Warren Schrader was with him. So we had some corporate knowledge within-house on this when we started planning. We knew from their recce they had identified probably about 25 pipes along that front face and a couple more protruding on the back side. We started talking a lot with, actually, go on to the next slide. So we had some base level knowledge, but there was even more that we didn't know. So we started really trying to reach out to all of the contacts we could think of to help us with this. The biggest unknown that we had, we knew they had placed, well, what we were told was TNT down those pipes, but we didn't have a lot of collective experience in our organization dealing with civilian explosives, especially those that have been left in the ground for 60 years. So my biggest unknown was the volatility of this explosive, what I was actually dealing with, and what the risks were associated with that, like sensitivity to shock, sensitivity to friction. So we reached out to DRDC, Pacific Blasting out on the West Coast were really helpful when we were telling them about this. They had dealt with some projects like this as contractors. CFEOD, couple other folks, but when we were planning to go up on the recce, that was a big thing we wanted to try and define, because that was really going to shape both our COAs, but also help me when I'm on the ground executing this, make decisions based on a good understanding of the risks associated. So we were reaching out to try and get someone to come up on the recce with us who had more background and experience. We struck out quite a few times, like CFEOD was a no-fill for it. The DTAL lab, they were tasked elsewhere. DRDC, we had a guy lined up, fell through. So we finally got Mr. Terry Sparks, a retired chief warrant officer from DAER, to come up with us, and ended up being really, really helpful. Next. So during the recce, Warren Schrader and I pretty much combed that hillside with LCMDs. We identified about 40 pipes. We had 25 confirmed hits, and then another 14 that we suspected. We took a couple samples, and we had 3 positive hits for nitrate when we did testing, but we brought one back to the detailed lab, and it tested positive for dinitrotoluene. So that was a good thing, as it's less sensitive to shock and friction. So eased our minds a little bit. We also gained a good appreciation for the remoteness of the site, but also a higher comfort level that we walked a fair bit around that site. We were a lot more comfortable approaching this afterwards. So coming back off the recce, the main message that we had back to feed into ADMIE was that this task is achievable with a task force probably about around 70 people. We figured we'd need about 17 days and that we could do it for in the ballpark of $300,000. From the recce, we were able to nail down. We were lucky enough to have a good chunk of our enablers up there with us on the recce, so medical, aviation, and if you go to the next slide there. So we were able to refine what we were going to need to take this on. So the big chunk, the field troop, 4 troop it was out of 2-4 that came up with us. The medical piece, ranger support was definitely going to be critical. Again, as Nick mentioned, this is 35 kilometers from the airhead, this island site, so aviation was going to be key, and it turned out that it was even more important than we originally thought, because the river, the water level was so low when we went up there that that backup course of action of using freighter canoes wasn't possible. The water was just too low, so we were entirely reliant on air mobile support to get in and out of the island. And then a couple other chunks there, MPs for airframe security. Next. We refined our schema maneuver, so broke it down into the real chunks that we had to look at for planning there. So mainly getting ourselves that air deployment piece of getting ourselves to Pewanik. Again, knowing that we had to go self-sufficient for the entire duration of the op, because it's a very small community, very isolated, so there's no chance for LPO if we forgot something. And we wanted to go to avoid a costly sustainment flight in the middle. We figured if we planned it well, we should be able to go without that. So that was a big planning chunk. Then that forward deployment, so getting us onto the island, the execution, and then the reverse of that to get us off the island and home. Next, please. So also during the recce, again, it highlighted a couple key concerns and supporting plans that we had to develop. So one of our big concerns was medevac, or medical support, primarily because we assessed it to be a medium risk operation, but coupled with the remoteness of the site, we really need to make sure we got this one right. So we developed a multi-phase medical plan. Basically, the Air Force was tasked to provide CASEVAC and medevac, but they ended up really biting off the CASEVAC chunk more so than the medevac, and HSS sort of filled in the gaps there with the medevac piece. So what we ended up with was Griffin. While we were doing the high-risk operations, we'd have a Griffin forward staged at our Martel Island camp, it would be called forward to the gravel pile in the incident of an unintended explosion. It would do the CASEVAC back to Pewanak Airport. That phase, when we did the CASEVAC rehearsals, turned out to take about 30 minutes for that portion. Next. And then from there, we needed that airlift, that medevac portion, to take us to the nearest surgical facility. So NATO standards, we often talk about the golden hour, but actually the NATO standard is 2 hours from time of incident to surgical bed. If you look at those flight times alone, we weren't able, and couple on the half hour to get them to the airhead, a half hour to stabilize, we weren't able to meet that window with any of these COAs. So what we ended up with, though, next slide, was a solution that we were all comfortable with. So we had a UMS, a good setup there with a doctor at the airhead. We had medics staged forward at our task site, and then we ended up with a civilian contracted aircraft staffed with air medevac crews, the same folks that used to do the repats from Germany. That air medevac crews out of, the capability is based in Trenton, but they actually came from all over. So that seven-person team surged in for that key 6-day window when we were actually doing the higher risk operations. Otherwise, we still had the Griffins on site, but if we needed to medevac, it would have just been a call to Orange, just like the rest of the community. Next, please. Water supply was another challenge, just based on the fact that we were going to be on the island. All of our resupply was going to be via sling loads in, so just the volume alone. So we were able, working with PMEDs and actually a PMED over at CSOR had a lot of helpful input for us. We purchased this system. It was called the Selden Water Box. 75 pounds, comes in a Pelican case, can be run off a generator. We ran it off, but anything, a 12-volt battery or a power pack eliminator, that sort of thing. And it could produce, it was easily able to sustain, I would say, up to a squadron plus size element, but producing about 80 liters an hour. So answered our problems and reduced the draw on our aviation assets for resupply. Next. Also, this will be an outstanding tool for us as a light squadron within our organization now. We've got that capability, so very helpful for future ops for us. Next, please. Public affairs. We did a lot of interface with the community while we were up there on the recce. We had a meeting both with the town, with the band council, and with other reps from the community, and we determined the best way to get, talking with them, the best way to communicate with the community and get messages out when we need it to let them know about explosions or when to stay out of that area was through the community Facebook page. So working with the public affairs folks, they told us we can't post onto their page. So Sergeant Matthew Gull, who was our ranger sergeant and an essential part of this operation, anything we needed to get out, so like the frequently asked questions in the bottom corner there before we went, he would post it on our behalf. The first time we did a detonation down on Martel Island, Matthew ended up with about 10 people from the community calling him, very concerned that something had gone wrong. So in the future, we would let Matthew know before an explosion he would post just to alleviate concerns from the community. Next, please. So to get us up there, 5 Herc flights, 2 with passengers, the rest with gear. Then we took on that next phase of the sling load deployment forward to Martel Island. That took us about a day and a half, 30 sling loads in total, so the choppers were quite busy. The Martel Island camp, you notice on the picture there, it's really not textbook parade square format. That was based on following Nick's recommendation, and Warren Schrader was very big when he was setting this up, telling the guys, minimize our footprint, don't cut down trees, put your tents around, fit it around. So when we actually pulled out of there and left, all that was left on site as a footprint were our few foot trails, very minimal impact on the site. Next. Just an idea of the ground we were dealing with. So the gravel pile there, and you can see our camp location about a kilometer, just over a kilometer back, that we would walk each morning to get down to the site. Next. So starting off just before, in those couple days between when we got out to the island and when those medevac assets were on standby, we had a bit of prep work to do on the site, a lot of brush clearance just to enable the search operations. Then we really approached the site clearance much like a minefield clearance operation, so dividing it up into those 1 meter lanes and then respecting the same sort of safety distances, so no more than 2 people within a 20-meter spacing when they were actually going out to do the search, any sort of positive action on the pile. That was also important because our medevac capability could only support 2 Pri-A casualties at any time, so we wanted to make sure that in the case of an unintended explosion, we wouldn't be doing our best to make sure we wouldn't be pushing them any more than that. This grid system was really helpful for just documenting what we found. It made it very easy. Next. So once the check in the box, CASEVAC rehearsals were done, and that medevac assets were on the ground, that was our key to go live. So the guys started doing a detailed search lane by lane. Next. As they would find pipes, they would excavate in. Again, we would excavate in to about that 2-foot mark in case we had to go with the backup COA of, cutting them off at that point if we weren't able to extract the pipes. So they would dig them out. That would also, as you'll see later, we were trying to pull the pipes out of the hillside, so freeing up that space around it. As they were doing this, as they were working intimately with the pipes, they would douse them with nitroglycerin destroyer. As an extra safety measure. I'll talk about that a bit later for basically chemical neutralization of any remaining NG. Next. So as the pipes were located then, they were documented and tagged. So by lane, the first 2 numbers that you see there would be lane 31, and the second 2 digits, pipe number 1 in lane 31. So again, we had a very good tracking system that allowed us to get a really good picture of what was actually going on in that hillside. Next. Some of the pipes we were able to, they were close enough to the surface that we could excavate them manually. This one we found on the north side. This was the first one that kind of gave us an idea what the start state was here. This one was in its full length, so 21 feet with one crimped end that we figure they crimped the end so they could jam them in, and then it still had the cap on the other end. So that one gave us an idea of our start state that we were dealing with. The other picture there, you can see the holes from the excavation, so it gives you an idea of how the pipes were distributed, at least on that front face. Next. So our original COA, we wanted to hit as best the SOR as we can, so we were aiming to completely get these pipes out of the hillside rather than going for that limit of our detection equipment. So our primary COA was to try and pull them out. We have, within the squadron, we've got 1 advanced mountain ops qualified person and 1 complex terrain instructor. That's an intermediate course between AMO and BMO where they really focus on rigging. These skill sets, it actually amazed us what these guys were able to do, and it drove home the value of these skill sets, not just in terms of mountain mobility, but rigging and light engineering applications. Like everything that they were using for this, you could easily carry on your back, like ropes, a small 3,000-pound winch. So they set up these systems, again, pushing the limits of what they had learned on their courses. With a small 3,000-pound winch and small power source, we did a couple attempts. We had 1 successful pull on the first day, so it got our hopes up, but as we tried more and more, we weren't having a lot of luck. So the guys got more creative. If you go to the next slide, they tried a 3-to-1 mechanical advantage, so boosting up based on how they set up the rope system, the output on that winch to 9,000 pounds of pressure on the pipe, less what you lose due to friction in the redirects. And eventually they got it up to a 9-to-1 mechanical advantage where the small knots in the system were failing before the system itself failed. So they were very excited about it. Even though it wasn't working, they were pretty impressed with themselves and what they were able to achieve there. But for us, it really drove home the value of these skill sets for a light engineering squadron. It was, we need to keep getting people on those courses. Next. They even went to the point that they went door to door in the town looking for a stronger winch system. We got a set of chain falls, Matthew again helping us out there, but in the end it wasn't successful. Next. For the pipes that we were able to get out of the ground, we were looking to, we had a mad pit established. The pipes would go in. We were cutting them into manageable chunks, like probably about 1 meter in length, so that we could again, ensure that they were free from explosives. So either extract, soak them with nitroglycerin destroyer, and then extract anything left in there and make sure they were good to go before we brought them for final disposal at the community dump. Next. As we were doing this, so this is where our ammo tech really came in. He took this piece aboard and started doing the extraction. So again, before he would do anything, he would soak the explosive well with the nitroglycerin destroyer. That was, the NG destroyer was basically, DRDC and Pacific Blasting sort of helped us with this. It's a solution of methyl alcohol, sodium hydroxide, and water that breaks down nitroglycerin into benign components of nitrate and glycerin. So really helpful for something like this. So he would soak them, and then we found that we were dealing with basically he classified it into 4 states, the stuff that, the remnants that we were dealing with. So up top, type 1, just the really degraded mud, sludge, very little energetic properties left. Moving across a little more, you could see a little more of the granular consistency. When you got down into type 3, it really exhibited a really strong smell of almonds. Like you could tell you were dealing with something different from up top. And then we found some that were still in their intact state. So trying to develop our COA, the pulls weren't working, so we were starting to look at this more like, what do we do with this? We did some control testing on some of the material extracted, basically hooking up just a DET to it to see if we were able trying to test the volatility of it, see if it still had energetic properties. Most of the tests we did came back nothing more than the DET popping. So we were getting more comfortable with the idea of introducing a charge down the tube. Initially, we had stayed away from that because we were, again, worried about that sensitivity to shock and friction. But these control tests were making us a lot more comfortable with the idea. One control test we did on a stick that was still intact was inconclusive, but we were fairly certain that it did high order on that one. Next. I've already hit really on this one, but that's just a couple shots of the nitroglycerin bath over on the side, or the NG destroyer bath, and our ammo tech doing his work there on the extraction pieces. Next. So becoming more comfortable with the idea of introducing a charge down the tube, we decided to go with the route of explosively destroying those pipes that we weren't able to get out. So for a lot of them, the front chunks were mangled and we just didn't have a clear path down. So we do a cutting charge on the outside to open up the pipe and then introduce what the guys coined as a carrot charge down the tube. So with a thumb knot and a quarter block at the far end, and then inserting that down and back close to where the limit of that 30 to 45 centimeters would be, another charge just to ensure that it would be cut off at that point if it wasn't completely destroyed already by the detonation of the charge pushed down it. Next. So that's the way we went, and things started moving forward quite quickly once we made that decision that the pulls aren't working, because that was taking a lot of time restaging in between. You can see on the picture on the right there, the detonations in the hillside, the backside, but also the left fireball portion there, that's our map pit, so doing the cuts on those pipes. Next. So in doing this process, we had a couple interesting results. Several of the pipes, there were 3 pipes that we had just put the cutting charge on the outside, just trying to open up so we could introduce the carrot charge down it. And 3 of those pipes actually ended up, well, 2 of them were completely destroyed when we went back to excavate to find the pipe so we could put the carrot down it. So 2 of them were destroyed. And the third one, you can see it was opened up completely along the vertical axis there, as if it had been completely lined with explosives. So that led us to conclude that there's no reason those pipes that we hit with the cutting charge should have been destroyed, other than if there were still live energetics in it. So twofold revelations, I guess, on this one. One was that the procedure was working, that if there was anything live still left in here, this was going to take care of it. And secondly, it reinforced to the guys that we weren't there for nothing. Like, this clearly showed us that there were still live energetics in this hillside, and they were taking care of them. Next. This is just a summary of of the overall results. So of the pipes that we located, there were about 97 in total. 50 of those were what we considered really the main effort. Those pipes that had been embedded into the hillside specifically for the purpose of loosening the gravel. Of those 50, we were able to pull one, and then 41 of those were explosively destroyed. The others we were able to manually excavate, but you can see basically the pattern around the hillside of where those were located. So mostly concentrated on that front face, but there were about 13 or so on the back, and most of those we actually missed on the recce. We only found about 5 on the recce, but that was due to the really dense brush back there. Next. So again, most of, so 41 of those 50 explosively destroyed. The ones that, those other, say, 50, 56 or so, a lot of those were fragments from when the OPP was up there. I forgot to mention, we actually sat down with the OPP constable who had been there before we went. He talked about that they got triggered to go up there in 2006 when a local from the community actually cut off one of these pipes and brought it into town, and they were very concerned about people going up and messing around with the site, so they, the OPP went up there and cut them all off at the hill face. So a lot of those pipe remnants that we found were just remnants from that, but other ones that we were able to extract, and those remnants, we packaged them up, and after inspection by the ammo tech and treatment with nitroglycerin destroyer, we brought them to their final resting point at the municipal dump in Peawanuck. So next slide. They were all transported out. This is the chopper coming in for the first load to be slung load out to the dump. Next. Following that, we had Nick come up to the site and do basically a site inspection to make sure we were compliant with the SOR and make his recommendations. And the following day, we brought the community up there, a bunch of the elders and BAM council members, just to do a site handover with them and make sure they fully understood what we did there and the state we're leaving it in. Next. So the benefits of this operation, from our end, it really was a proof of concept for our light engineer squadron. Like, we had the right skill sets, the right people to make this happen, largely self-sufficient in terms of, you know, having those guys with those sling load qualifications on each end, those guys with the mountain op skill sets, the water supply. It was outstanding from that perspective for us. Skill-wise, I mean, the proficiency of the guys with the mine detectors, be it the LCMDs or the F1A4s, rose exponentially. So that search piece, refining our skills in that sense, just getting creative again with problem solving and developing that puzzle as we went through. Yeah, their search skills, demolitions, confidence in their equipment, all really valuable for that. It also was outstanding for us to get that joint experience. So like over on the far side there, that's one of our air crews all kitted up to go do some, get some experience with demolitions. Down in the bottom quarter, that's Warrant Schrader doing the pre-flight inspection on the Griffin. And we had outstanding support throughout from our ranger counterparts. Like, they were really, especially again, Matthew Gull, but rangers on the island with us doing that wildlife security. It was really valuable experience for that cooperation. Next. We also, again, we asked for 17 days, we got 25, so we had some time to do more training while we were out there, taking advantage of both, you know, the helo assets that we had, but also survival training with the rangers, 303 ranges. Like I was mentioning, the guys got creative with problem solving. Like, we had to man one of our sentry points. You had to cross the waterway there, so they built what they called the modular cot bridge, just so the guys could get out there without getting their feet wet. Guys were really thinking outside the box, and in terms of, you know, team cohesion and just, I guess, pride in what they had done. I would read them out, the messages that we got forwarded from various levels of the chain of command, like once we had accomplished the test, and they came out of there really, really proud of what they had done. So for us, like, outstanding team cohesion experience. Next. And also, I like to think that, you know, we walked away with a really positive outlook on this First Nations community. They gave us outstanding support throughout, you know, just really helpful, really friendly, and I hope that we left them with a positive impression as well. Again, in that time that we had between when we got back off the island and and redeployment. We built a hockey rink in town. The community was coming out and giving us soup and sandwiches while we were building. They hosted a potluck. Our MPs were going to the school to give talks to the kids. We just had a lot of really good support from the community and a lot of good interaction with them. So from that end, again, I think we both benefited quite a bit. Do you have anything more there on benefits?
Just in terms of benefits, the biggest part is the Mid-Caroline, the bigger environmental project. There was going to be trouble closing that off because of this outstanding explosive risk on the site. Because we were able to get the CF to get up there and do it, and the bigger thing is that if we had a contractor actually do it, they wouldn't have done such a thorough job. They wouldn't have scoured the hill like they did. And so to be able to, one, get rid of some significant obligations and liabilities that the Department of National Defense had, and then on the other half, to provide amazing training for these guys and get them up using their equipment, it provided a really double benefit. And so if there is an appetite going forward for this kind of these kind of joint interactions, the biggest thing is coming forward is, one, make sure there's a good SOR, that you actually know what you're getting into, and then two, making sure that it's prioritized within the leadership so that there is enough juice basically coming down the hill that whoever gets the task at the major has the means to go out and actually do it.
And just, again, next slide there. Most of these I've already hit on, so I won't cover them again, but in terms of lessons learned, we really drew a lot out of this. Big one, early joint planning with all those supporting elements that need to come together. The second huge learning point for us was that air movement planning piece. Again, totally outside our comfort zone. We found that even within our unit, we didn't have a lot of those key assets that we needed to help us plan this little stuff like dangerous goods, cargo. We also didn't have the time to dedicate beforehand. Like something like this, I think you need a good 6 weeks of dedicated time. We got back off the recce, finished IBTS, went on summer leave. We came back, we had a week at work. Then we went in the field for 2 weeks on a live fire exercise, came back, had a week, and we deployed. So the time, we didn't have the time to dedicate to it. Luckily, we had a very good 2IC and SQ that managed to somehow pull that together and get us up there. But I guess the last one is just experience with northern operations. I went into this with the typical Army mindset that your priorities are based on accomplishing your mission. So when we deployed forward to Martel Island, the first sling loads that were coming were our comms gear, and then our ammunition and explosives, and then food and water, and then somewhere down the line was our tentage. And halfway through the day, the weather turned really bad, started to get pretty nasty out there. I wasn't sure if the helicopters were still going to be able to fly. I had 30 guys sitting out there on the site. So when it comes to, and I looked over and the Rangers were in their tent and warm and comfortable, so it drove home that when you're up there in that environment, you really need to set your priorities. Like priority one needs to be that survival piece, and then the mission essentially can come next. That's all I have. Next there. If there's any questions.
Can I just make a comment now? The biggest thing with this, my takeaway, is many of the troops we have in 2-4 Field Squadron right now, the younger guys, they join the Army to go to Afghanistan and chase down Taliban. But we don't have that mission for them. So, they wanted to do mission. Yeah, this isn't an international deployment, it was a domestic one, but we got overseas. When we treated it as the clearance op, I think we maintain that skill set for a minefield clearance task, like everything right down to that scrap metal pit and stuff. So 10 years from now, when there's possibility of being back into that international deployment, where we may be doing some, we still have that skill set. Even if it's just 1-2 of the guys that did this operation. So I think it was really key in terms of training and treating it as that specific clearance task. A lot of the guys, like the OC mentioned, they just walked away with an extreme amount of pride and stuff, which is good to see, and I think we need to do that, especially this day and age without that mission. That's my 2 cents.
Yeah, and we were up there for a good 7 days, sitting just outside the community, waiting to go home. We didn't have a single disciplinary incident the entire op. So
we pieced together this group from right across the country and different trades and arms and stuff without the luxury of having that pre-deployment training. We got on the ground, everybody knew what they had to do, and they did it. So the professionalism was really good to see. And yeah, not a single issue, so. Thank you.
So if there's no other questions, General Whitecross obviously had to go away. She's got another meeting, but I'd just like to thank you, Warren Schrader and Nick, for an outstanding presentation, but more importantly for the terrific job that you did on this task in making us all proud. I think many of us are at the points in our career where we kind of live vicariously through what you guys do now. And I must say, we've discussed a number of things today, and while I was kind of excited about the Pantones and the engineer flag, I got really excited about listening to what you guys are doing there. And I think what struck all of us was the ingenuity and the creativity that came through, that just, I think, the hallmark of the Canadian military engineers, and just is really proud. And as an adjunct, this got a lot of exposure. I mean, what you guys did, and sometimes you may not realize this, I mean, your division commander pumped that right up to the Army. The Army commander was aware of this. This was briefed at CDS Ops, and it was really high profile, and it really put that engineer stamp on what you guys are doing. So once again, well done to you guys, and well done to your soldiers. I think we're really proud of that, and thanks for a great briefing.
Thank you, sir.